Hi, I'm Kaushik. I work at the University of Dundee as a machine learning scientist. Today, I'm going to speak on this topic called demystifying machine learning. This is not a lecture, but this is a demonstration. So I want it to be interactive. You will be able to participate in this using this QR code. Please keep your mobiles close by. Or you can either go to this website and type this code. I'll be asking few questions and you'll be able to participate in by giving answers interactively. So let me start with this first question. What do you think is machine learning according to you? I have already received some beautiful answers. So most of them have said prediction, simplification, algorithm, yeah, big data. All these are very, very interesting, especially Alexa. Yes, there is AI, machine learning in Alexa, this technology. All this is fantastic. So I will tell you who this demonstration is for. This is not for somebody who has been doing machine learning for years. This is not for experts. This is neither for somebody who has absolutely no clue about any of these terms. Somebody who has never heard any of this. Obviously, if you are listening to this, you have definitely heard at least some of these, and probably not an expert. So my intention today is to demystify some of these terms so that you will be able to associate some imagination or some emotion, some thought whenever you come across these terms in your media or newspaper or on anywhere else that you would come across these. So this is the intention of this today's demonstration. So let me start with artificial intelligence. So AI has wide applications, but the term AI itself is too abstract. It is like love. If you ask somebody what is love, love can have completely different meaning depending on the context and depending on the person you are asking. Like, I love my dog, I love my Indian curry, I love going for a hike in beautiful mountains. So love can be very, very abstract. Similarly, artificial intelligence is actually a very abstract term, and generally there is no consensus between experts as to what exactly is AI. So nobody actually have an agreement of a perfect definition of AI. AI is something which is up in the cloud, so off. But then why are we discussing AI if this is the case? But there is something else within AI which has a context, which is meaningful, and experts agree about its uses and definition and how it can have an impact. So this is machine learning. Whenever anybody says AI, generally they will mean machine learning in some or the other way, applied along with other factors. But I have also seen AI term being abused in various ways. But anyway, but machine learning is something which is tangible, which people can understand and have a specific definition of. So and this machine learning actually has all the tools, techniques, methods, and algorithms which are used for AI. So this is what I will be discussing today. And whenever I say AI, I'll mostly mean machine learning. And within machine learning, there is a very specific kind of machine learning called deep learning. So deep learning, you might have also heard of neural networks, artificial neural network, various other jargons. So this is a very specific kind of machine learning. The machine learning field itself is very, very vast, but within that there is deep learning where you can let the machines learn on its own in a very specific manner, unlike general machine learning, in a very specific manner which can have immediate relevance in a particular problem solving area. If this is too jargony again, we will come to it in a few minutes time. But mostly for today, whenever I say AI, deep learning, whatever, I will be sticking to machine learning. That's what I mean, because if we understand some of the jargons of machine learning, then we can also understand some of the jargons of deep learning, and we also know what is the context in which AI is being used. So this is, this is how I would say, deep learning is a box within machine learning, which is a box within artificial intelligence. So again, another question to you. What does algorithm mean to you? Please, please go to menti.com, or if you're already there, you can also type in your answers. What does the name algorithm mean to you? Because we would have come across algorithms so often, whether it is machine learning, AI, deep learning, algorithm is everywhere, and people refer to algorithms in popular media. So I'm curious to know what you think is algorithm. I think you can type in answers for 3 times. You can up to 3 times you can answer this question or any question. Yeah, I see a lot of answers coming in. Good. Yeah, guidelines, rules, flowchart, process. Yeah, all of them are very interesting. Again, the question is not to trick you or judge you in any way. This is for me to understand my audience. And as I said earlier, there is no wrong answer to these questions. So whatever you say should be right because the question is according to you. Yeah, learning habits, methodology. Yes, process, programs. I see process appearing several times. That's why it is big, which is fantastic. Complicated. Yes, we will try to demystify this complicated word today. That is one of my objectives for this demonstration. Yeah, in the interest of time, I will just move on to the next slide. But thank you very much for your answers. So algorithm is nothing but a recipe. Yeah, I will come to it. I will explain this. So let us say you want to bake a cookie. By the way, I have never tried baking myself. So if there is something that I'm saying wrong today, don't blame me. I don't bake at all. I've never tried it. So let us say you have ingredients, butter, flour, and chocolate chips, etc. And now you want to go from these ingredients and make a cookie. What you do is follow a recipe. So here is the recipe, which is just a set of instructions which you need to follow in a specific manner to go from ingredients to cookie. So this is a perfect analogy for algorithms. Algorithms are no different. They also have to follow a particular set of instructions to go from data, whatever data you give them, to an endpoint. So whatever you want to achieve from this algorithm, by using this algorithm. So this is the recipe is an example of algorithm already. I'm sure most of you should be a better baker than me, and I'm sure you would have done all these things because I've never done it. Even if you have tried it once, you should be better baker than me. So here in this recipe, you are following set of instructions, like you have to preheat the oven, whatever these instructions are, and then beat it until the mixture is creamy, and then you have to stop after whatever baking for whatever minutes to get this cookie. So this is how recipe is a perfect analogy for algorithms. Algorithms are no different. So you have to follow all these instructions in the particular order so as to go from data to whatever you want to achieve out of it. For example, if I had started not with these these ingredients, but I had started with something else. Let us assume let us assume I have all the ingredients, but not chocolate chips. So I'm sure I would still achieve this endpoint if I had to, if I follow these instructions. It will only be that it will not have chocolate chips in it, but still, I would arrive at a similar cookie. So what I'm trying to get here is the same recipe can be used even if some of the ingredients are missing or different. Like if the recipe indicates usage of a particular kind of flour, if I don't have it, if I have something alternate which is not too different, I could still follow the same instructions to arrive here. So you can use these recipes in slightly different ways to achieve at nearly similar endpoints. It might not be identical, but it might be similar. But if you don't have a few ingredients, or if you don't have some tools, for example, here it says you have to preheat oven. So let us say we don't have oven. If we have only microwave oven, then I'm sure this recipe is irrelevant. So because do you think I will go and buy an oven just to bake one cookie or once a cookie using this recipe? I will almost certainly change the recipe and figure out if there is a recipe that I could use to still start from same ingredients but reach to more or less similar cookie. I'm sure there should be some recipe. It might not be exactly tasty cookie like if you were to use actual oven, but I'm sure it shouldn't be bad either. So in this way, you can use slightly different recipes to still achieve same or similar endpoint, or start with a different starting material, which is ingredients, and still achieve similar endpoints. So analogy is just like the way we saw here. To achieve same task, you can use different algorithms depending on what data you have and where you want to get to and how quickly you want to get to, or you can repurpose these algorithms in slightly different manner. For example, the chocolate chip, if the chocolate chips are not available, you can still follow the same so as to get this similar cookie, but the cookie will not have chocolate chips. But that's okay. So in this way, you can play around with algorithms as well as you would do with the recipe. But then, how to choose the best recipe? What is the right recipe? It depends on so many factors, like how hungry am I, or your friend. So will your friend be willing to wait for eternity till you make the perfect cookie possible? And what ingredients do you have, and what tools are available to you at that instance? So all these things will decide which recipe you would follow to make the cookie. Similarly, algorithms are no different either. You will have to choose the right algorithm depending on what is the time that you have to achieve the task, and what you want to achieve at the end of this task. So in that manner, I will take one example. Let us say we are in Dundee. I am in Dundee. Let us say I want to visit several places in Scotland for a holiday. Of course, this is a bad weather to go, but let us say I'm driving anyway. And what do you think? How do you think can I cover all these places in an efficient manner? Like, I want to save fuel, and I don't want to drive around haphazardly, wasting fuel. Do you think, again, another question is coming, please keep your mobiles ready. So do you think, is there an algorithm to help me figure out the best path possible so as to be fuel efficient in my journey? So here is the question. Do you think there is an algorithm to help me plan my journey? And if so, how many? Is it 0, which means there is no algorithms? But I see a winner already. 1, 2, or many. It is indeed true that there are many algorithms to help me figure out the best path possible. I'm giving away answers. Sorry, if I have not let you answer it on your own. In fact, the question that I posed is a very, very well-known question, and it is commonly called as traveling salesman problem. It has been known for a very, very long time. And there are several algorithms which can help us figure out the best way possible. But the most important thing here is there is many, but none of them are perfect. None of them will give you perfect answer. There is no perfect answer at all. So this is something that you should take away right away, that no algorithm is perfect in giving me the best possible path, because there is, at least as of today, there is no such solution for that problem. But there are still several algorithms that I could use. So Before going to unsupervised learning, I just want to give another example, like especially for people from Dundee or Scotland, because this is something that that we experienced over the summer. So we wanted to travel to Stonehaven. Obviously, I chose Google Maps to look for the best path, but we were not in a hurry. I was not in a hurry to go to Stonehaven. For those people who don't know Stonehaven, it is just north of Dundee. It's a very beautiful place to visit, and it was on a Sunday. We wanted to have a outing, so I was not in. We were not in a hurry to reach Stonehaven. So when I searched Google Maps, it gave me an option of taking the motorway A90, I believe. A90 is a motorway which goes inland, but I had already heard from people, Scottish people who are here for a long time, that the path which is right next to the sea is very scenic, and I should take that path. So if I had gone with Google's suggestion, I would have completely missed the point of having this beautiful journey. So even Google, even though it has the best algorithms or whatever, did not provide me with a solution which I was hoping to receive, because the algorithm was optimized for time. So it was suggesting me a path which would let me go from Dundee to Stonehaven in the shortest possible time, not necessarily beautiful. But for me, the priority was having a beautiful drive with my family, which is definitely not through A90. I mean, I have never traveled in A90. Probably it is beautiful as well. But anyway, but I'm sure the path or the route next to the sea was scenic. We stopped all over. In fact, it took us probably 1 hour more than if we were to travel through A90. But who cares? We wanted to have a beautiful journey, which is what I was using these algorithms help for. So what I'm trying to get here is, so first of all, algorithms need not be perfect, and they cannot sometimes provide a solution which will be optimum, because what it is optimized for can be completely different from what you want to achieve from using this algorithm. So there are completely different things. So there are several algorithms to address this particular question, and there are also thousands of more algorithms to do several tasks within machine learning. So now we are going to the next stage, which is unsupervised learning. So there are two broad categories of unsupervised learning. So what I mean by the term unsupervised learning is you are letting the machine learn without your supervision, without you going and telling something is specifically A and B, whatever. You just give the data and let the machine figure out using several algorithms what it can from the data. So there are two kinds here, which is dimensionality reduction and clustering, the two very, very important steps. And there are several algorithms within these to do various tasks. So the easiest way to understand dimensionality reduction is through a demonstration. So what I will do is I will come out of my presentation mode, and I will show you this I will demonstrate this using something that I have set up at home. Are you still seeing me? I hope so. Okay, yeah, I see thumbs up. So I have, I found some things at home, and I have made this screen. I'll be using this screen here. I'll be placing this here, and I have a torch. So if I place an object behind the screen, obviously you can see my hand shadow. So I'll be using this to demonstrate something. So what I want to demonstrate here is dimensionality reduction. First of all, what is dimensions? Like, obviously we exist in 3D. So if you take a cube, one edge can be x-axis, another can be y-axis, and another one perpendicular to these two, it will be z-axis. So there are 3 axes, which becomes 3 dimensions. If I want to reduce from 3 dimensions to 2 dimensions, then essentially it means that I have to take a shadow of this on the screen. So my cube, which is in 3D, has now become a square on this shadow. I hope you are still able to see. If not, please let me know, Ilsa. Yeah. So in this way, I am able to easily identify what the object is without actually looking at the object, but just looking at the shadow. I'll just have another example. So again, I'm taking a projection, which basically means a shadow. So same here. This is another smaller version of the same cube, and this appears as a square in 2D. So I have just done dimensionality reduction, going from 3D to 2D. I've taken another object now. Let me see if you can guess. Yeah, if you are looking at the circle, you would have probably guessed that it should be a ball, which is a sphere in 3D. Yeah, if you have guessed it right, then kudos. Yeah, one more. Why not? Yeah, this also is a ball. So in this way, you can clearly identify objects in 2D, though you are not seeing the same object in 3D. But then I will show you another object. I hope I will get this correctly. Yeah, I think you can immediately recognize this object. This is my specs. Now you have done two things, three important things now. One is I have done dimensionality reduction. I have gone from three-dimensional space, which is where the specs exist, to a shadow, which is 2 dimensions. And because you know how a spec should look like, looking at the shadow, you could immediately identify that this should be a specs, which is what is called pattern matching or pattern identification, because you already have a reference pattern using which you could identify and correctly determine the shape. And there is another feature, probably some people might have noticed it, that let me see if you can get this correctly. Yes, that one of the corners is broken. It is indeed broken. Yeah, my specs broke last week. So you also found some interesting features in reduced dimensions. So what I'm getting to here is you have just done 3 things: dimensionality reduction, pattern matching, and third is identifying some key features which you wouldn't expect in your reference pattern. No, obviously you wouldn't expect the specs to be broken when you saw the shadow, but you did see that the feature existed, which means the specs is broken. So all these things can be done in several steps. I'll just show another couple of other objects. So let me see whether you will be able to guess this correctly. If you have guessed this as a ball, then you are wrong. So dimensionality reduction is fine. You can do a lot of things, but you should also be cautious, because not every time you will get the right answers. Because if I had projected it this way, you would probably think this is a rectangle of some sort, but the edges are clearly showing off. But anyway, if I have projected it this way, then it will appear as a sphere. You would probably assume this to be a sphere, but both the answers are wrong. But because this is a cylinder. So what I'm getting to here is how you do projections matters. So most often, just doing it once in a particular axis, along a particular axis, like this, or like this, or like this, just along one axis is not sufficient. You will have to do it 2 or more times, depending on the number of dimensions, to get an idea of how the object should exist in a higher dimension by looking at several shadows of the same object in lower dimension. So this is also important, because there are chances that we can be fooled quickly without realizing that we are fooled. Another object again is this one. This is completely, I don't know whether I'm getting this right, but this is very hazy. It's probably not very clear. But if I turn it on the other axis, you can clearly see that it is another kind of cylinder as well. But in fact, this is a bubble blower, whatever it is. So how you project also matters. Even if the same object is exists in whatever dimensions, in however you project, what axis are you taking while you project does matter. This is another concept called principal components. So principal component is nothing but axes along which you can capture best or more diverse features for a given object. So you will generally project or make shadows along the first and the second principal components, which basically means you are projecting the same object in 2 or 3 fashions, which can best decipher the details of the object in lower dimensions. I don't know if it's a big sentence. So why I'm saying all these things is you can be doing the same steps, but how you do these steps does matter. Like I said, pattern matching, dimensionality reduction, feature identification. So let us say you do one step. On top of it, for the same data, you do another step. On top of it, you will do another step. So this is one tower of a particular order, built in a particular order. Now you might not do it in the same order. You might build another tower with slightly different order. You are still doing the exact same steps, but the order is different, which means the product that you get out of it, the answer that you get out of it, will be completely different between the two, because order does matter. Not only what you do with the data, but how you do and what steps you take does matter a lot. So these two, though I have used identical blocks, they are completely different because they will give you completely different answers. Yeah. So this is my short demonstration. Now going back to my presentation, I hope you are still able to see this. So yeah, next comes the clustering part. So I have few animal images here. So what is the best way of clustering these animals? Now obviously these should be clustered together because they are all mammals, and these should be clustered together. This is one obvious way of doing it, but is it the only way? Probably not. How about this? If I only consider legs, number of legs or just legs as one important property and forget everything else, then obviously all these have legs, but snake has no legs. So snake will be clustered in a completely different cluster wherein these will be clustered together. So this is one way of clustering. Considering that we only we only have legs as a property during clustering. Second is, how about lifespan? Now, if I consider lifespan, the turtle and elephants usually live for more than 100 years, whereas these have more or less 15, 20 years of lifespan. But lizard has the shortest, probably 4 to 5 years of lifespan. So if you consider lifespan, the same animals will now exist in different clusters. So what property you are considering to perform clustering will depend how the clusters will exist, how the animals will be clustered into. So again, question for you, keep your mobiles next to you. So I want to cluster these into two clusters. The obvious way is the elephant and dog should go into one cluster, because if I consider legs, tail, and obviously they are animals, why would I want to cluster it in any other way? However, can you think of properties where which would give you an answer wherein this elephant will be clustered with a tree? Can you think of properties where elephant will be grouped with the tree and not with the dog? So weight, fantastic. Dimensions, yes. Size, trunk, yeah. Lifespan, good. Yeah, dimension is also a very important answer. Water content, very interesting answer. I didn't expect that. Yeah. So for example, dimensions, like I can have a dog as my pet inside the house, but I can't have a elephant as my pet inside the house, right? That is definitely true. Lack of fur. Oh, very interesting answers. Yeah. So you are getting the point. So there are two things that we did just now in the context of clustering. First thing is by changing what properties you choose, same animals can be clustered differently. In the second one, we want an endpoint. I want to group elephant with the tree, and now because I have decided what the endpoint should be, now I am cherry picking some of these properties which would let me reach the endpoint that I want to. So again, the point I'm trying to make here is there is no perfect way of doing anything here. It all depends on what you are trying to achieve. So depending on what you are trying to achieve, you can tweak around several of these things, several of these details, and get to where you want to go. So yeah, you have already given the right answers, and even answers which I wasn't expecting. Great job there. And the another kind of machine learning is supervised learning, wherein we by the way we just saw unsupervised learning. Here there is slight differences, wherein you are telling the system what is what, or telling the machine what is what. There are two kinds within this, which is classification and regression. I will come to this right away. What is classification? So what happens here is you give something called label data. Basically, what is label data? You are labeling the data and then telling the computer that this is cat. All these images are cat, all these are dogs. So you are labeling it and then providing this for the computer. And you will choose some of these features. Again, feature is a jargon. Feature basically means properties. What property are you choosing? For example, if I were to choose number of legs, then it is not uniquely defining cat from dog because they both have 4 legs, but probably shape of ear, shape of eye color. I'm not an expert in this, but there will be obviously some features which can better uniquely define cat as cat and dog as dog. So those features can be selected and then used for training. So with an algorithm of your choice. Again, there are several algorithms to do this. And once we do this, this becomes our ML model or machine learning model. And this model can be used further with new set of data. What I mean by that is, this model has already seen these kinds of cats and these kinds of dogs, but it has not seen this particular cat, which is different from all the cats here. Similarly, it has not seen these 2 dogs from all the dogs that it has seen. So this becomes our training set, and this is a new data that we are giving. But because it has, hopefully it has trained very well, it will be able to predict that this should be a cat and this should be a dog, because it has seen several other dogs and cats, and it has managed to understand that what should be defined as cat and what should be recognized as dog. So this is how classification works. Again, regression, keep your mobiles ready. It's very easy to do regression with a question. Let us say I ate 1 apple on Monday, 2 on Tuesday, 3 on Wednesday. How many do you think I will eat on Thursday? Yeah, I know it's a silly question, but that's okay. Yeah, it's obvious. So you see the point already. Like this is what is a regression. Actually, there are 2 things that is happening. You are doing least square fitting and then extrapolation. But again, these are all jargons. But the idea is you have a trend over a period of time. You have data for a trend that is changing over a period of time from the past, and now you want to predict the future. So if you know how my eating habit has changed over these 3 days, you can easily tell how it will change, or what I'm likely to do on Thursday. So this is the essence of regression. Thanks for your answers. Moving further, this is a slightly different kind of regression. I wouldn't call it regression, but it is it's a kind of imputation, wherein you don't have all the data points. By the way, I will first of all read the question. I'm sure you will be able to read this as well, but let us assume I ran 2 miles yesterday. I intend to run 3 miles tomorrow. How many do you think I ran today? By the way, this is completely fake question because I did not run 2 miles yesterday and I'm not planning to run 3 miles tomorrow. For the sake of question. Yeah, you got the answer correctly. I mean, again, this is all silly questions, but the point that I'm trying to make here is there is no mist surrounding these terms. I want to declutter and demystify all these jargons. So what you just did is actually imputation, a kind of imputation, wherein you have data points in a series except for one which is missing. Now here you have data from yesterday, you know the data of tomorrow, but you don't know the data from today. So it should be given it is 2 miles from yesterday, 3 miles from tomorrow. It should be 2.5, which is basically taking an average. But it can get more complicated in specific cases, but this is the essence of doing imputation. So in this way, like I just showed with Lego blocks, you can rearrange all these steps of dimensionality reduction using different kinds of algorithms to do regression or classification, or how you do it. All these things can be rearranged just like this Lego blocks, and several options, several combinations can be tried to figure out what is the best output or best strategy that would work for your particular use case. Usually, in my work area, it is healthcare, like drug discovery, diagnosis, personalized medicine, and especially since the pandemic, we are all aware of public health and how data sciences and machine learning has played an important role in understanding the public health, and flattening the curve is so widely known nowadays. So in this way, you rearrange all these algorithms, all these strategies, all these steps to achieve what you want to achieve, thereby using the best use of the data to predict the future. But everything is not rosy. There are some limitations. Model bias is a very serious thing, wherein your predictions can be biased, and there are several reasons why it happens. But we should be aware that whenever we use any model or any predictions, there might be some caveats to this. It especially happens if we use this as a black box approach. There are several tools, several algorithms that are already available, wherein you just click, and then it can build some prediction model for you. And if you don't understand how exactly this is working, then it becomes a black box approach, and that can be dangerous actually. And you can't generalize these models either. For example, if I have trained a model to predict cat or dog, and now suddenly if I give it a fox image, it will predict something. It might still say it is either cat or dog, but it would be irrelevant. Just because a model has been trained to identify cat and dog as correctly, I can't give it something else and expect it to perform because it is not built for it. If I wanted the model to predict fox, then I would have used fox also during the training process while building the model. So it has to start from the beginning, and I can't use these things in a very generic sense after the models are built. So these are some of the caveats of all machine learning models. And how do you overcome this? So domain knowledge is very important. Like obviously we all know what is cat and what is dog. So if people were to use some specific data sets without knowing what the data means, then it could be a terrible thing. So you have to know the domain knowledge. For example, in my own case, because it is drug discovery, healthcare, I need to understand what exactly the data is, who generated it, why was it generated, what is the context, what could be the challenges in data generation itself. So basically, I have to understand the data very well. By understanding the data, some of these problems can be approached or mitigated. And interpretability, again, there is no I can't emphasize it any further that interpretability is very, very important. There are exceptions, especially in deep learning space. There are exceptions where you still can't interpret but could use, but there are very special cases. So interpretability is important. You have to understand what are the steps, how exactly is it going, what are you doing at every step, and what order are you doing these steps in. And as I already said, you can't generalize. You have to know the applicability. Where exactly are you applying? And education plays an important role. So when I say education, it is there are two kinds of education in this. One is, as a machine learning scientist, we have to learn the domain knowledge ourselves. Because we need to understand the data and understand what it is saying, and how much to believe and not to believe. Sometimes that there are some problems associated with the data, and it could be a challenge. So we need to understand. So education also comes into picture as a scientist for myself. And there is second kind of education wherein it is our responsibility to educate people who will be using our models. Like if I'm a machine learning scientist, if I generate a model, it is my responsibility to tell the users that boss, this is okay to use in certain context, but it is completely stupid. It might do some terrible things if you use this outside its context. Or I could also say that this is if there is something unexpected that happens in your predictions, I could say that please come back to me so that I can learn from this mistake and use a better learning strategy so that my models in the future can be better. So yeah, so there are various educational aspects as well. By doing all these things, you can really achieve very good approaches in building a better model. So in summary, I hope I have demystified some of the jargons. I wanted it to be very, very simple, and I'm sorry if I have disappointed some of the people who are experts in this audience. But the key thing, the key message that I want to convey here today is there is no single right way of doing AI, but there are innumerable wrong ways of doing AI or machine learning. So if you go away today with only this single message, it will make me happy. Again, another question for you. What do you think is an important skill to be AI scientist? Is it communication? Is it math? Is it collaboration or collaborative nature? Is it computer science? Is it domain knowledge? Again, domain knowledge, again, in my context is drug discovery, but the domain knowledge can vary depending on where you're using this AI algorithms or machine learning algorithms. For example, as I already said, they have been used even in policing. Even in the UK, they have police use some kind of AI in working out where exactly to deploy their troops. They have already used extensively in space exploration, which means the domain knowledge will be space. We have to understand all about space and etc. Yeah, I think the answer is very, very clear. I was hoping to see this, by the way. The answer is everything is important. So that is the key. If you lack one, then it will be it will be a challenge. So everything is important according to me to be a successful AI scientist. No one is any less than the other. Another question for you. What do you strongly agree with or disagree with? So AI is evil, it will take over our lives. Do you strongly agree with it or disagree with it? Or AI is magic, it solves every problem? Or AI is useful if you use it in the right context? Yeah, interesting. Interesting patterns are appearing. So I'm able to do some pattern matching and deciphering right now. Yeah. But I think a pattern is appearing. So because I have come across many people telling me that AI will take over the world and all these things. I don't think that will happen anytime soon. And it is neither magic. It can't solve all the problems. As you already said, it couldn't even tell me properly how to reach Stonehaven in the most scenic way. So if it cannot do this simple thing, then What? Anyway, so if you use it in the right context, it can be very, very potent. So that is the point that I'm trying to make here. Yeah, thank you for the answers. So yeah, if you have any questions or feedback, if you type in as a chat function, I'll be happy to discuss and answer your questions. You can use either menti.com, or you can also directly put in the chat box of the Teams. So either me or Ilsa would be able to see. Currently, I'm not able to see Teams. I'm only seeing this presentation, but I'm sure she is able to see chat as well. So if you have any specific questions, I'm happy to discuss. I will just come out of presentation mode. Okay, thank you very much. Yeah, thank you very much. I can still read your messages. Thank you, and you're free to also put it in the chat. Yeah, I think over to you, Elsa. By the way, thank you very much for joining.
Yeah, thank you everyone for coming along. This is a couple of times Kaushik's run this now, and it gets better every time. If you have any questions at all, please feel free to email us in your Eventbrite email. If you reply to it, should come straight through to me. So if you have any further questions, feel free to send them over. And I know, Kaushik, you have a Twitter, so feel free to promote your Twitter. And always you can follow WCare, which is the Wellcome Centre for Anti-Infectious Research. Feel free to follow us on Twitter at WCare Dundee. So yeah, thank you everyone for coming along. The session has been recorded. I think I actually started 6 minutes in, so I've missed the first section, but I'll be putting it up online anyway. So thank you everyone for coming along. I hope you have a lovely evening. Thank you all.
Thank you.